What's going on, everybody? We're live. STL Sunday, 3D printing Sunday, laser cutting Sunday today. Hopefully everybody can hear me. We'll see that everything is working. My monitor's finally catching up, but see how it goes. Today, what we're going to do is Fusion 360 again, like always, every week. But wanted to kind of go over a topic that I've covered in my Road to Scale Nationals video here recently, and that was having some parts laser cut and then, by an outside source. And in the case that I've been using, it's sendcutsend.com. I've linked them in the description below. They sponsored the Scale News update. They're not sponsoring this video, but they're still linked, and it still shows that I sent them traffic, which I appreciate because then in the future I have a better chance of working with people. What do you know? So anyway, what we're going to do today is I'm going to just show you the process, because laser cutting is a little bit different in the fact that it's a 2D cut. They use flat sheet and they cut a hole all the way through. You're not cutting half depth or adding features like a 3D printer where you have a lot of flexibility. So you just think a little bit differently. It's a little bit more simple, but it's different in its own way. But there is some tricks to actually getting from a design file you have on your computer in Fusion to what you need to send to somebody like Sendcut Send to produce your part. So that is what we're doing. Thanks for checking in, everybody. It looks so slick. It's a constant joke because this is Ben's Scale Crawler Fab Shop shirt that he sent me. It's super soft. But I'm like, every time I wear it, I'm like, it's such a slimming shirt. I feel so like I don't need to eat less. I just need to get more of these shirts. So hopefully everybody's having a good Sunday morning. And yes, I trimmed my beard down because it was getting ridiculous. Soy latte because I live in California. Let's get into this. All right, let's switch over to our Fusion setup. Here's a blank document. Today what I wanted to do was because I wanted to show you guys the process of something like, say you want to create your own brand of chassis. You just want to get into that game. Now, I obviously know how to do it. I still have several chassis from other people here because it is work. So, and there's a lot that goes into a lot of these things. But I want to just show you what it would take for you to design your own custom flat rail style chassis. So let's get into it. Like I said, we are going to start with this is going to be a 2D, not a 2D sketch itself. That's what we need to end up with, is a flat part. And we can get into a lot of details about that, but I want to keep it fairly simple. Now, I created a sketch, but I'm going to undo that. One thing that I'm going to do is I've got an SCX-10 2 based car here in front of me. And we're going to pull some measurements off of this because this is something that a lot of people have, and most likely when you want to create a custom chassis, you want to take something you have and modify it to fit more of a situation for you. There's reasons you could be wanting to do a chassis, and that could be you've got like a custom hard body or some sort of custom build in general that you want to fit something to, and maybe something isn't easily available, or you just want to build something custom yourself. Brett is in here, Mr. Brazen Scale. Obviously, he's one of the guys who makes flat rail chassis, who I use. Even though I could draw it, I find it sometimes just like picking them up. But like I said, we're going to go through this. So I'm going to use some dimensions off of something like an SCX-10 And the reason that I said that and that I started that whole conversation is that I still want to draw this in a way that is typical to my 3D process. Because even though we're going to output a flat part, we still want to have the, information and ability to draw the rest of the parts in a 3D space. So I bring that up because I want to just design or take the measurement for the outside to outside of frame rail, which I don't know off the top of my head, but we're going to go with 78 millimeters roughly. And I'm going to go construct up here at the top, and we're going to offset the right plane, and I'm going to go 78 divided by 2, and that's because that way it keeps the center line of the truck on the center plane. And then we're going to start our sketch on that plane. Now we're going to use just standard SCX10, SCX10-2 skid plate spacing, which I'm going to try and remember off the top of my head. And I believe that it is 65 millimeters to the outside holes. And I think the inside ones are 35 millimeters, if I'm not mistaken. No, it's 65 and 38. That's what it is. So that's the standard skid plate bolt hole pattern for the side of an SCX10 style skid plate. Doing a construction line between the holes and putting them on midpoint, so it just makes it all, the same. We're gonna make these holes, since we're doing laser cutting and for a regular, we're gonna do 3.2 millimeters, and we're gonna make all of those equal to each other. There's that, right? Now, we're gonna take construction line off. We need to start drawing just some of the normal profile stuff. Now, again, this is gonna be this is going to be the easy part of chassis design, and that is just kind of designing something like this, and then it really gets into all the tweaking and clearances and cross braces. That's where a lot of the hard work comes in, but it's so we're going to go, let's go with, whoa, what did I type there? 40. We're going to go 4 on the bottom, and we're going to go a little bit taller on the top. Something like that. Again, this is not a fully designed deal, but we're just gonna give you something. Now, this SCX10-2 chassis that I have here has some modified shock mounting locations, and let's for the sake of this video, we're just gonna go with something like this positioning. So I'm going to measure from the known points that I have, like from a skid plate hole on the chassis, to kind of give myself the approximate shock mounting location. So that is roughly 90 millimeters forward of the mount and say 70 some millimeters height-wise. So we're just going to put one hole up there, 3.2 millimeters, and we're going to go from that location. We said 90 millimeters forward. And we said roughly 70 millimeters high. Now at this point, we could do a quick rectangular pattern, just grabbing that, and let's do 3 up, 3 down. We'll do -12 in that direction. And we already had -12 that direction. There you got a simple little array of shock mounting locations. A very common situation on flat rail chassis. Now we're gonna measure from that exact same hole in the chassis and grab our rear position. Rather than starting to mix and match, try and keep the same datum. So we're gonna go 155 millimeters, and then we're gonna keep the same location, or same height-wise. 155. And I'm just gonna throw a construction line between them and throw a horizontal constraint. Go down, we're gonna do rectangular pattern again, select that same hole, 3 at 12. Oh, I've got construction line on. That's okay, I can fix that. 3 at 12. Oh, I didn't have it on. That's okay. So we've got that. Now we need our overall distance. Now we could shorten it up. Sometimes these chassis are a little bit longer than needs to be. So let's go about 150 millimeters on the front side and 220 to the rear. For an off construction line. 3.2. And back here, 3.2. I'm going to do, we're going to throw just the, I said 150, right? And then I said 220 to the rear one. 220. Now, perfect chassis for Lloyd. Kind of looking at height wise to the front, stock is maybe about 20 millimeters from the from this location to where the bumper is, but let's raise that up. Let's go, let's just raise it up 10 millimeters. We'll go 30 total. And in the rear, let's do 35. Again, these are just kind of random numbers. But what we should do is we should match the rear bumper spacing that is commonly used on things like SCX 10.2s. So that way you can make it so that it mounts up to most common things. And I should know this spacing, but I don't. But we're gonna go with I don't know, like 8.5 millimeters. That's a real rough estimate. So 3.2. Now the nice thing is that with 3D printing, you could probably, prototype a lot of this stuff before you send it off. Just not, it's not going to be functional, but it's going to get the job done enough to, double check that your hole spacings are correct and things like that. Whoop, that one's 3.25 all of a sudden. That. So a lot of this is now I saw someone say, am I going to do actual like Fusion 360 based tutorials? And I know I don't do a very good job at going through and explaining exactly how I'm doing that. A lot of this stuff, I have gone through some of it. It's, it's all just, I feel like I can get some of this stuff done that's maybe a little bit more tuned into RC by doing it this way and not going through like just the absolute basic stuff, which some people have some really good tutorials on already. So that's why I'm like kind of not as worried about doing the absolute like entry level of the basics, but not, and mainly because other people are so much better at it than I would be. People that are, Lars Christensen is one guy who does a fantastic job. Oops, I did not get that on the midpoint. So let's, I don't have that height wise, but I'm just going to give it like a quick measurement here. I'm going to give it about 4 millimeters from, that seems about right. And then we'll call this whole section about 10 millimeters tall. So what I've done here is I've gone through and I've defined a bunch of just kind of the critical points. We've got bumper mounts, shock mounts, skid plate mount. Like there's the basis of a lot of your custom chassis stuff. Now there's other common things like people do, like say where your rear links are, you want some more adjustability there. Let's do that. Let's do another rectangular pattern. Select that. Let's do 12 by 3 again. give you some there. But let's get rid of these two. We'll just turn those to construction lines, something like that. Now, in the front, maybe we don't need that same amount. Maybe we just do 3 vertical, just because, you know? Never really mess with anything in here. This just gives you a little bit of something to play with, right? But again, what we've done is created the basics of what we need to start connecting dots and then creating your version of a custom chassis. If we want to maybe think about this a little bit more, let's put in some axle position stuff. So I'm going to just drop in a couple of circles. These are going to not denote the actual size of the axle or anything like that, but it's kind of going to give us a range of things. From, we're going to say roughly 130 millimeters forward of that forward link mount, the same place that I've been measuring everything. It seems off. How far off am I here? 100 that's about right. What did I really yeah. I really shortened up the front of that chassis. So it was at about 107. So I took out about an inch off. Let's take this to about 160. Still shortened up a little bit from the factory one. But gives us an idea. So that's okay. And then we can kind of just say that we've got a 313 millimeter wheelbase. That's always pretty easy to think about. So I'm just going to put a horizontal line between them. Now, that's not fixed to anything, so we can still kind of move that up. But the reason I did that is I want to just kind of take and just kind of think about it coming upwards. So, as you get a lot of suspension travel, you can start this thinking about like, well, I'm going to have, these axle pieces that are going to start coming up and colliding into things. So again, this isn't a hard fixed size or anything like that. It's just a size. So let's just start let's think about adding some more room in that area to make sure that we've got some space. And then we're just going to we're going to give this some shape. You can do, hard fixed lines. You can do arcs. You can do whatever you want. That's what differentiates so many of these chassis from each other. We can kind of go up and then we can do another kick. I kind of hate that. Kind of don't. It's not the point. Now, of course, the intended, what you should do is go through and fully define all of these things. Like that is the proper way to go. I am not doing that, but that's, it's just not what I'm doing right now. So we're not going to tie into that endpoint because we want that to be parallel to it. So I'm going to just make sure that I'm getting these lines at least parallel to each other. Those should be. That is, I've got it. Don't need that. And now let's do I'm going to use the slot command and just to go around the top of these. About 8 mil, that's fine. I'm going to go down. This is just giving me some sort of, radius to connect to. Making sure that I'm tangent on them. In the rear, we're going to do a quick version of the same thing. Do 8. quickly kind of tie this in the back. Let's kind of go. And we got our shock mounts up there above us. We got to tie into those still, but we'll get there. This is all just the rough part of it. And of course, we've got lots of opportunity to add and change style because that is important. I really hate basically all of this. We'll get to it. We'll get to it. I'm going to do that same slot method for the top. This is why I hate it most, because it's just this massive area. But maybe we can, like I said, we can change all of it. Again, this is all just the graphic part. This is just style and what makes so much of that a thing. Now, we didn't do an angled skid or anything like that. It's not really any harder to do. You just, add either an angle to your base part of it when you start the design, or you could angle the rest of it, but I feel like that would be kind of funky to do. I absolutely hate this. I can't do it. I can't allow that look. Oh, I had some. Okay. Let's something. This is the pain in the ass part of it. Just getting all these lines to start dragging around and looking not silly. Get rid of that line. We're just going to tie it all in straight in the rear. That's fine. Something in there. We do need to get that on. Down there. And I need to add the tangency to make sure that it flows. Oops. I still need to add just some width to this stuff. I'm going with 10 millimeters, depending on the thickness, depending on your material choices. All of that can be, too much or not enough. It just depends on your choices, and that's kind of all up to you and what you think will be strong enough for whatever your application is going to be. So I had fixed that one onto the top there. I kind of figured that would be an issue. So there we go. Hold, please. Now, the other part of this is that once we do export it, we're gonna upload it to the Sendcut Send website. I'll show you guys how that goes, and just show you pricing too, because this stuff can be super affordable. So while this is terribly ugly at this point, we're just gonna go with it, and I'll show you as we go how we can clean this stuff up. So we do need to go to our thickness. I don't know their thicknesses that they have available offhand, but let's just go with, we can go with like 0.125 inch, 1/8 inch, which is thick, but it's fine for now. Now, with lasers, you do have the ability, fillets and all that kind of stuff. Oh, I forgot to get that front part knocked out, but we'll get there. Let's add some fillets in here. Start getting some of this stuff to look not so kindergarten level. This is not going to end up wildly attractive no matter what we do, because we're not sitting here staring for hours on end to come up with what we think will look the absolute best. But that's not the point of today's exercise. Just grabbing all this stuff because fillets make everything better. One thing is we do need to go back and, oh, I didn't put anything around that. That's why. We gotta fix that. I'm using the slot command a lot today, but it's very handy for this type of stuff, especially. I think it's underutilized. But why did it not think that, oops. Why is it not pulling that up as a closed profile area? That's interesting. Don't have an answer for that yet. Sure seemed like it should have been. Oh, it just wasn't graphically displaying. That's okay. Isn't there other things to figure out in like space for servo mount? So there's always things like that to figure out. But since we went with things that are fairly similar to like SCX-10.2, you know that we can go with, you know that we have an area that is going to, the things that are going to work. We're going to be able to fit those type of things in there. It's all, and if you've never done one before, then yeah, it's lots of time to sit there and think about it. But we're pretty confident. Now, things that we do need to add for those type of things are things like holes for mounting. We need to add areas back here, cross braces, servo mounts, any of that stuff. So those are absolutely things that we still will have to mount. I mean, otherwise we'd just be sending this file right now because it's got the thing. It's got the mounts and the cross braces, but we're going to just break it up a little bit so that we can. I'm going to do an offset. We're going to do like, we'll do an 8. 8 there. Gave us it back there as well. We'll do a line across here. It's not level yet, but that's fine. We're going to just put a construction line between those lowest 2 holes. And put like a 5mm on that. Actually, I'm going to increase this to, let's do 10. It doesn't want to let me. That's okay. We'll do another one. We're not going to chain though. So we're going to select these and go up -10. That way we've got -8 around the upside, but still have that 10mm frame rail portion that's coming in. And we're going to do that same back here. We do not have chained selection selected. -10. Okay. We still need to do our horizontal line. Do one there too. What did I say over here? 5. Let's drop those knockouts out. Couple of holes there. And just doing this so I can add some radius. What's a 5 look like? Oof. What's 3 look like? 3 is better. Let's go with 3. Added something there. Now our shock towers don't look as bad. Something simple and easy. Let's go back. And what we need to do now is we need to throw in some locations for things like servo mount, panhard mount, etc., etc. So let's do. I'm going to do something like this. Now, with 3D printing, this would, having a curved or a cross member with a break like this, not a problem. If you were trying to make this like a mass production type thing, you'd probably want it more flat so you could machine it rather than using 3D printing, since 3D printing isn't always the best approach. We're going to center these in the frame rail at 5 millimeters and make sure that this part is parallel. Five again. Now, we do need to, let's just put that first position straight vertical. Something like that. And then we'll make this rear one 30 exactly along that distance. Do 15. I don't know that that's exactly evenly spaced, but at least it looks better to me. Why not just do a 4-link in the front? I mean, you can, then it doesn't matter. It's nice to have holes in the chassis for cross braces and things like that. But if you're doing a chassis that you want to be flexible for scale competition, things like that, then it's good to have provisions to add those things. I would suggest it, at least, to have the ability. 4-link's it's an easy way out for sure. And it's way easier to design around. It doesn't take much work as far as a lot of that stuff goes. We're going to throw 2 more holes back here is probably fine. Especially because this is just a exercise anyway. So let's throw this one at a logical point, like right there. Straighten it out. 30 millimeter spacing seems fine. There we go. Now I did the... So what we have done here is created what is still a flat rail. Now, most flat rail chassis actually do have some taper, meaning that the cross brace designs will be narrower than if these are just, the width of the skid plate. It helps taper them in, makes the chassis a little bit more rigid, gives you more clearance for shocks, things like that. But it's not necessarily something you have to design into it in 3D. You don't lose that much distance with the bend of it. So I'm not going to tell you to get overly hung up. Now, from here, the rest of this starts getting into a lot of the other, you got to design cross braces. You have to design, put your skid plate in there. You could look at shocks. But if you're kind of just taking a known working vehicle, pulling some of the things in that you have and just modifying a little bit from there, you can get away without having to do nearly as much of that work. So that is kind of what we're talking about. That's probably the thing that is most common thing that hangs up builders. But builders is the width difference between the skid and the bracing. It is, because they'll bolt in the skid plate and then they get these cross braces and they put it in. It's like, well, this cross brace isn't wide enough. It's like 4 or 5 millimeters too narrow up here. And you're just being like, yeah, you just got to put the screws in and just start working it in. It just helps make that chassis become more rigid, because if you guys have ever, if you have a box, like a box design, you can kind of wiggle it. It doesn't have any inherent rigidity to it. But if you have a triangle, of course, then it's one of the strongest shapes, because it braces off of each other. And we don't have that, but we're starting to have that. You bring those in, and then it just makes that whole chassis have a lot more side-to-side rigidity. It's a simple thing that actually it's got more than one purpose, beyond the fact that it's just way easier to do these type of things than a molded C channel. It does help it to actually bring it in a little bit. So, but this would be the start of it. From here, we could start designing cross braces and bumper mounts, things like that. And if I was designing this for a long-term process that I wanted to be absolutely dead nuts, what I would probably do is draw this shape like I have here. And then I would probably have a second shape that had the proper bend to it, so that I could start designing all the rest of my clearances just exactly correct. Let's not get into that fully, but I'll show you a quick version of what that process would be to me. I would take and say, I would just, off of that inside rail, Brett, rough numbers, what are you doing? Like, I don't know. You're doing 3 millimeters per side? Let's just say 3 millimeters per side. You don't have to tell me. Say 4. I don't know why. Doesn't matter. So I would take that. I would take and I would project the front of the chassis onto there. And this is way overly simplified, but need it. I just want a section that's tangent. Something like that. And I would go 0.125 inches in. That's a new body. So I would take this, and then I would connect from here back to I would have a copy of this outside rail, and I would basically connect those two pieces to just make it so that it's a representation. That way, I actually extruded this the wrong way. It would be to the inside. It's not nearly that much of a taper in most cases. I've got, I don't know, like 3 or 4 or 5 flat rails here, but they're not that drastic. But when people see like this gap, they're just like, I don't know what to do. So I would have that on both sides, taper it back out, giving myself a good representation of it, so that I could design my cross braces and feel like I have an accurate CAD model in a way. But so anyway, that's a lot of talk for really no benefit. Sorry. Let's say you've gone through the entire rest of that process though, and you have what this is going to be your final part. One thing to remember with laser cutting is you can't have any half steps. You can't do like a half cut down on most lasers, specifically lasers that are like cutting metal. Yes, you can do it on some where they're like making a half depth pass. For this type of thing, that's really not something you're going to see. This is really what, in the end, you're going to want to have, is something as simple as this. There's a number of things to do. Like you could go through and then make a drawing file from this and export, but that's a long way around, and it's actually a huge pain in the ass. The easiest way for any of this, for any part that you have, is create a new sketch on the part itself. Because we created this with a bunch of different sketches. You know, we had 5 or 6 sketches to create this. So we created a sketch on that, and we're just going to hit P for project, select the whole face, and do that, and finish sketch. Now, if we turn off the bodies, we're left with that sketch still, because that's the only one we haven't used. It's just all right there. Now, the easiest way to do this is find that sketch in your menu, which is this one here. Right click, save as DXF. And this is just going to be STL Sunday. That's a terrible name. This is going to be the, I think, what did Ben say? JSpeed. This is the Jason Speed Ultra Fabulous Chassis. There you go. So now we have that export, and that is really all we need to then go to our website. Now I'm already logged in on the website. So basically log in, whatever, to upload your own. And you would just go drop files. So let's go find my file here. So just, I found it in my Explorer, and we're just going to drag and drop it in. And processing. It was in millimeters because that's what we were drawing in. So that makes it easy there. Now from there, we just select what we want it to be out of. Say metal, aluminum, if we want it to be light. 6061 is pretty common. That's really what you'd want to do for the most part. So this is what I should have done. Oh, they do have 0.125. So it's good to design with known dimensions, thicknesses, widths, whatever. So I should have came here and confirmed that they had this, but 1/8 inch aluminum plate is pretty common. So select that. So now if I wanted one of those rails, it would be $11.91. If I want 2 of them, they're $9.53 each. So $20 for 2 rails. Now their minimum order is like $29. So you would have to, either get some other parts or get enough of them so that it added to at least $29, because that is their minimum. That's yeah, this chassis will be sold at amain.com. But so you could add that, and then deburring is free. It just cleans it up, makes it so there's no sharp edges. Add to cart. $19.06. You can see that the subtotal down here though, it says $29 because it has to be at least $29. So if we go back to our drawings, we could go back to that part and say we wanted maybe you want to like weld to this chassis, like build an actual cage or tube work off of it. Then I would suggest steel, but probably not that thickness, because that's going to be pretty heavy. You could go 100 thou. That would be, CRS is cold rolled steel. So let's see. And so again, $10 each if you do them in steel. Add to cart. There you go. You could have 2 of your chassis rail sets for about $40. That's that's the pricing's pretty good on this stuff. There's not a whole lot you have to worry about as far as it goes. Pele is saying it's worth noting that a hole in a laser cut part shouldn't be smaller in diameter than the thickness of the material. Oh, shouldn't be smaller than the thickness. Yeah. I guess that's not something I run into a lot in this. It is, I guess it's worth noting, but 100 thou hole is really small. I guess an 1/8 inch hole. Well, 1/8 inch is still, I guess that is a case in this because I'm technically right at it with this one. 0.125, a 3.2 millimeter hole is, see, 3.2 divided by 25.4, 1.25. I am just over, since I use 3.2 most commonly. So I'm just over. I guess, yeah, worth noting. But yeah, that's not something I have technically ran into, I guess, all that often. So I don't know that I ever really go anything thicker than 1/8 inch. So in RC at least, definitely. But really, that's what I wanted to show. Is just that the fact that you could go from a design like that, export. Honestly, I've been so happy with Sendcut Send. It's just been so easy, and the pricing has been so good that it was just. I've been using it a lot just because of it. You know, I can't help but be super satisfied with that whole situation. Where's Sendcut Send located? They're in the Reno area, so they're not even that far from me, which is another nice thing because they're actually super fast with getting everything done. And then it gets in the mail, and I don't have to wait long for the mail because it's just 3 hours away from me. But the mail part of it is obviously something that is going to take longer based on your location, most likely. But everything else has been so fast and quick that I've been obviously using this a ton because of that. And again, yeah, like the price isn't bad. If you want 2 aluminum rails, you're less than $20. That's shipped. Shipping is free. What? You just have to spend the time to be able to learn CAD to draw it yourself. That is where the rest of the investment comes in. Because if you don't know any of that, it's like, well, I don't mind paying $70 for a set of rails that is definitely going to be more worth my time than designing it myself. But if you have something that there is no option for your application, like it's hard to beat. You know, you got a custom project, $30 is a minimum, and shipping is included in that. And I mean, unless you're in the Great White North, some chassis companies will be out of business at that price. There's a lot that goes into the rest of the chassis business, though. You know, just the ability to support, you have to design the rest of the braces, including that stuff, or however you're going to do it. Like, there's a lot to this stuff. By no means do I think that this is going to put chassis companies out of business, because once someone tries to do this stuff themselves, they'll understand that there's a lot of effort in there. And I mean, for me, like, I can draw this stuff, but is it worth it all the time? Like, my brazen scale over here is going to be the one I'm running at nationals, just because I was able to. Everything was done. I was able to get a chassis brace. I was able to put this stuff together. I know it's a chassis that's been worked out and it has proper clearances, so that I don't have to spend 30 hours or more, really fine tuning a design. And, this is a version, I don't know how many versions Brett has had of this chassis, but it's like, you're paying for the time that they've put into, designing and making these platforms work. So there's lots of reasons to do different paths. I think that, especially if you are a builder, though, and you just want to have your own thing, you want to design something yourself, you want to call it yours from start to finish. I really enjoy that part of it. That is something that I will always push people to do and learn, because I think that's part of what can make your RC car hobby, help push you into other areas and make you more well-rounded on all parts of it. But this was a design that would likely have some hiccups. Technically, that is a V1 of 2 versions. There are probably 25 non-release prototypes involved. That's that's the difference, is that you're working with you start taking that price that we looked up, and it's like, oh, if you have to do that 25 times, that becomes kind of a pain in the butt. But that's the difference between making a business out of it and making sure that it works for customers and everybody versus making something that you know is going to work for you in your one type of application. So I have no, I don't feel bad about doing this video and showing you how you could create a chassis yourself, because it's not like it's just the easiest thing. Now, what is funny is that we threw this design together, and I was actually thinking, I was like, that actually looks a lot like the, let's see, XL chassis TCS. There's a lot of similarities between this and the chassis that I designed like, 2009 or so, 8 maybe. Like, one of the early flat rail chassis was the TCS X Trail, and this was it's one of the early scale chassis. It was to take an AX10 and convert it to a scale truck, which was not a thing really at that time. And I designed this chassis back in the day called the X Trail, and there's just some very noticeable similarities with how I did things then and how I do things now. Like, everyone has their own design styles and things like that. Yeah, you can kind of see my shock mounts look similar in ways. This chassis was out before the SCX10. Then the SCX Axial paid me to build them one. They sent me an AX10. They was like, hey, build with your. I built with the X Trail chassis, sent it to them. Then the SCX10 came out. So I'm just saying, I take credit 100% for the SCX10. I don't. I'm kidding. Not that guy. Kind of that guy. Not that guy. But I definitely have some similarities. And it was just, I still have an X Trail on a TLT. Oh my God. Wild. So that's really what I wanted to push out to you guys. Just showing you, for one, just the last step of taking your design, projecting a sketch to the outside, and then saving that as a DXF. That is such a simple little thing that if you don't know that part of it, you're going to spend way too much time trying to create a drawing file and then exporting that as. And I think also the other thing is that I don't know that is there drawing from design. Nah, I don't even want to do it. I think that the free version of Fusion may not even let you do the export as DXF in the drawing side. So you almost have to do it this way, and they just don't make it obvious that this is a method. So they don't, it's not out there all that well. Is the 1/18th called the L Trail? It is. The 1/18th was the L Trail chassis. I did that for the Losi MRC, I think when I came up with that. That's when I used to design for. Correct, it does not allow exports to DXF. That's what I thought. So you have to do it this way. And if you didn't know this was a thing, you'd be sitting there pissed. So right click, save as DXF. Saves you a ton of time anyway. Activate your windows. Buck Dandy, shut it. I know, should do that. I don't know why I haven't. It's almost just a. I have 2 L Trail chassis. Jeez. Easy way to get a DXF is just put a sketch on the part you want to finish. Go to the bottom of sketches. Yeah, that's what I just showed you. But after, you have to do the whole thing. Finish the whole part, create a new sketch, project everything onto one sketch, and then export. That's what I had shown earlier. So the easiest way to do it. So. You can get plugins to export faces as SVGs or Yeah, but why? But then you got a whole plug-in. I guess that is nice, but you know, it's and can you? I don't know, how do plugins work on the free version? So I do. I pay for this. It's like I pay like $450 or $60 a year is what Fusion 360 costs me. But that's because I have, well, for one, I have a ton of files, and I don't want to have to activate and deactivate because you can only have like 10 active files at a time, which isn't that big of a deal. But I'm commonly working with more than 10 files in a day, and I also use this to make physical parts. So like I'll show you guys just quickly since I'm kind of done. This is only 54 minutes, but if I'm going to take this to, I want to actually machine it myself. I'll just show you what that workflow would be like. I'm just going to right click the body and go create components from body. So that makes this one a new component. I go up to the top workspace and I go to manufacture. So it looks very similar, but it is not. So I'm going to go into new setup because I need to define the material that I'm going to use. Now, right now it's trying to make a big piece of material for the whole thing. I'm actually only going to select one of these bodies. And from there, now it wants you to like decide what size material you're using. So side stock offset, I'm going to do like 6 millimeters. Just gives me a little bit around all edges. Now, I don't know why I did all sides there. Oh, that's because I know exactly why I did that. One thing I didn't do is I didn't define my axis, my model orientation. So I'm going to select X and Y axis here. So the X is going to be on the bottom, the Y then vertical. Now, I know my machine and I know that the Y is backwards. So it would be like that. So I'm just defining that how it would be set up in my machine. My stock point, I usually do top of material and top left corner. That's just a personal preference thing. I'm using a CNC router, so I've got a wood bed. I don't like to consider that always even and flat, so I use a tool length sensor to set my top of material height every time, just because of the type of machine that I have. Now, top offset, we're doing 0 because I'm just going to use the actual material that I want to use. So I would have that set up. That would be there. First thing I would do is I would go into drilling, select the tool. Most of the time I'm using not a drill. I'm using a milling tool. So, and I usually use, since I do a lot of carbon fiber, I do 3 millimeter. Oh, because I'm in just the document. So we're going to go Fusion 360, 3 millimeter, and I'm going to use a flat end mill. I'm actually using a PCB cutter, which is like this little knurled tool. And feeds and speeds, whatever. I don't run coolant. Whole faces, we're going to hit select same diameter. And we're going to select that. And then it automatically selects all of the holes in the chassis for me. So then you select the height. I will usually do a bottom height. I'll do negative 0.5 millimeters so that it goes just past the bottom, cleans it all up. So there's that. Then I would do a 2D contour. I would select the insides first, most likely, so that nothing gets loose. I would again do that same, negative 0.5. Hit OK. Oh, it's wanting. I'll just do aluminum slotting. That's fine. Doesn't matter for this right now. So it would do the inside. And then lastly, I would do 2D contour again on the bottom outside. It's got all of the same. So there you go. And that's, I would, 3 tool paths for what I have right there. And then if you wanted, you can actually hit like simulate. So it'll show you. Oh, I'm only simulating one tool path right now, but if I selected all of them and then hit simulate, you could see what it's going to do. So it'll go through and show you all of the drilling. Very slow for some reason right now. But it goes through and you can just confirm that everything you're doing looks like it's going to be appropriate. The other nice thing is that I didn't have any small radii in this, I don't think. So one thing I could check is that after the fact it gets done, I could go in and check all of the material left to see if I machined everything to roughly the size that the part should be. So that's kind of the point. Now I have been missing a ton of comments. Let me read this while that thing just, I could kill the simulation, but maybe you want to see it. You can get plugin, let's see. That is how I also have to do it when making brackets. Right click, save as DXF. Yep, definitely. Okay. What filament dryer do you use? I just got an ESA. Remember that? I actually never, I never use a filament dryer. I don't keep proper care of my filaments like I should. I don't keep them in dry boxes or anything even. What is the advantages of this chassis say versus a VS410 rail? I mean, the advantages to flat rail chassis are usually that they can be more, call them boutique. You know, you can have, they're easy to create, they're cheap to create, there's no tooling. They're just very simple, so you can make very specific versions for anything. There's not really anything to it other than just the design time. So that's an advantage. You can create them out of, like, say, flat stock aluminum, which makes them lighter. It doesn't make them maybe as durable as like a fully commercial product like a VS410 would need to be, you know, so that it works for more customers. You know, it doesn't have to have the things in it that make it like a good mass market product. It doesn't have to have all of the, you know, battery mounting things all super situated. It can have 3D printed cross braces. It doesn't have to be finished like a regular product. It's also, you know, there's a lot of things there that they don't have to do. They're not expected to do to be a regular product or a full, you know, like mass market type product is what I mean. Finally caught an STL Sunday. Thanks for joining. Looks like I've been inventing the wheel. You've just shown my work process. Look how you whiz around and make it look easy. A lot of this stuff, if you just get into it and like start, you're like, okay. You just have to get in there, and I've done it 1,000 times now. So all of this is to set it up to cut on your machine at home. Yes, this is how I just do for home. You know, this stuff. This is not something you would do for a laser. This is just if I'm cutting here at home. But, you know, that was quick. Now, technically, I could take and throw a sheet of carbon fiber on my machine and cut out a chassis if I wanted. So if I missed anything, it would show a red area, or, you know, or that would be if I cut too much. If I didn't cut enough, there'd be blue. These holes technically should have some blue around them because that's a 3mm bit and a 3.2mm hole, but yeah. How goes the $20,000 C-carb? That will be the rest of my day today. Well, that and class 2. I've got a big list of stuff here to do, and it's gonna be a big part of my day, the rest of my day. A little bit of this, a little bit of that, boom, best part ever. You can make more specific shape and not have to worry about the stamping process, and would require yeah. So that's the other thing, is like when you're doing a VS410 chassis, it's a stamped design to get the C channel, and you don't have to do that. And so lots of flexibility and ease since there is no tooling. Is Mr. Anti-Flat Rail making his own flat rail? I'm not actually making it. I'm just showing you how to make it. And we showed it on how you could send this to laser cutting and what the pricing on that would be. But this was just a super quick, we spent like 30 minutes maybe on this design. So not a lot there, not a lot into this one. Not saying that it wouldn't work, it probably would, but you could probably cut this and actually make a part that would, there's not a lot over the top on it, so I think that it would probably be able to be put together pretty easily. I wouldn't expect a lot of hang-ups or anything like that. No tooling except those of us who have to have more than 6 inches. I mean like tooling like stamping and, molds, things like that. That's where machines don't count as tooling. Machines are just the machines. Like, it's even for like me on my machine, tooling like a bit. That's not even tooling. That's just that stuff. Yeah. Ooh, Send does brass as well. Make a flat rail brass chassis for the Bronco. What would that chassis cost in brass? Let's see. Let's go drawings. Add to cart. Metals, brass. They've got 1/8 inch brass. $22 each. Not even that expensive. 30-ton press pegs. What are you press breaking? There we go. We've added our brass chassis rails to there as well. So we have an aluminum one, $20, $19.06. Mild steel, $20.42. Brass, $43 for the pair. Press break the world. How would you change for different scale? How would you change for different scale trucks? I don't know what you mean exactly. We went through at the beginning and kind of talked about how we placed hole position, so that might do it, as far as what you mean. But each truck or each scale, like you're going to have to do specific designs because you're going to have different skid plates, you're going to have different shock mounting positions, all that kind of stuff. So, and there may be something up my sleeve when these Sorka rules change. Are you going to put that cage up on Thingiverse for the cliffhanger? Yes. I plan to fabricate that possibly today. If everything works out, then I should be good to actually put that thing up. I went through and did all the revisions. So I believe that the cage fit is, well, you can see that the top bar in there, but the cage fits in there pretty well. You can't really see it, which is about what I want. Not that you can't see it. I just mean I want it to fit tightly to the body. So, but I think that it's going to work out just fine. So yeah, I do plan to put that on Thingiverse. So I'll probably do it when with the video upload, just in case anybody wants that. From 1/10 to 1/24. So that's let me go to I'll go back to Fusion, show you that. Where is it at? SCX24. So like recovery file. This was from September of last year. This was one of the I showed the chassis design like during the 24 scale budget build off, and this was not the one that I used in that. It was actually one that I never really never really showed. But I moved the battery into this little tray, back here. Now this was designed for CNC cutting rather than laser cutting, but because I've got like these half steps, which just aren't needed. But I actually tabbed and slotted this like rear tray design. And this was one of the Furatech Lizard, or I don't know, whatever, one of their funky named things. But I think this was a sliding rear body mount. And all these things just kind of like keyed together. I think this was a secondary. I don't remember what that tray was for, but basically getting into the fact about asking for different scales. You have to really design for what you're doing. You don't just scale. You need to go through and properly design. Make sure your skid plate bolts are the right spacing and all that kind of thing. So all of the same things apply, but you just have to do it for your scale. And this would be the same thing. If I was going to send, let's just grab that, P for project that whole chassis, finish sketch, drop down, we'll go find our last sketch in this, save as DXF. This was budget build Betty number 4. And let's drawings. We will go drag that into here. Say we were going to do this out of thin titanium. Like honestly, 1 mil would probably be fine. $5.93 each for titanium chassis rails for a 124 scale on Sendcut Send. So that's, and honestly, that one I could send, because this was a chassis that I had, like this is that chassis in carbon fiber. You can see that rear. I would need to make that piece out of, technically I'd need to make that piece out of 2mm or use carbon fiber still, because that's, then it would properly slide into place. But, this was designed for that front mounted PN Racing motor setup. The body mount up there, the whole deal. This is a fun little chassis. I really liked this one. This was just the last version of it that I never actually covered in the series. So this is the one. I've got the Power Hobbies 59 MG servo in here, which is a big servo. This one was pretty well built up. I just never really covered anything on this build. So yeah, I think that's about is all of that 24th on Thingiverse. Not this one. The previous version, the one that I actually covered, was on Thingiverse, but not this one. I just never got around to really covering much on this version of it. This is live. But it's it's the main thing I just wanted to show is that make your way through the design stuff and just hammer through some of it. Just make it happen. Dive in. Some of this stuff, even if it's something super simple, and then you can just have some parts made. And there's nothing cooler than drawing something and then getting like physical metal parts that are perfectly cut exactly like what you drew in hand. Like, it's so cool. And for 29 bucks, like, yeah, I'm just saying. Just picked up a really cool 24 scale project from Etsy. Been talking to the creator too. It's super nice. There you go. What the hell is that? A keychain? I mean, kind of like this. It's like almost the size of a real RC truck. It's It's like a real RC truck, but smaller. Buck Dandy, thank you, sir. If you would have, if you would have had your laser scanner, it would have made making that cage easier. Oh my God, man! I can't tell you how excited I am for that scanner for that reason. So, could have just scanned the cliffhanger body into Fusion and built the cage off of that. Yes, exactly. And one thing that I was like so badly wanting to do. It's definitely something that I'm going to dive into almost immediately when I get the laser scanner. I'm supposed to have it. I paid for it, and it's supposed to be here in like April or something, like late April maybe. Yeah, I'm just waiting for it. I want it bad. Still waiting on that cliffhanger interior. Yes, and that's part of my class 2 stuff, because I want it to fit the cliffhanger body, but on your chassis. So my previous one didn't fit the brazen scale chassis as well, so I'm going to make it much more appropriate to that chassis. That's my plan. And after that's done, it's all yours, Brett. So, and then I'll give you the file so that you have to buy yourself a vacuum former, because it's going to be too handy to not be able to make them. Oh, have a local guy who has the same vacuum former. There you go. Problem and solution. Well, as soon as I get the design done, I will share it with you so that you can make them. Is this live? Yes, this is live. Since I upgraded to the Series X, wait, what? I have an Xbox One Connect that plan to fool. So yeah, I've seen, there's lots of different versions of laser scanning. Even iPhones, new iPhones, a lot of them have LiDAR, and you can download an app and get some, and they work pretty well. The detail is not bad. I'm looking for just a little bit more detail, and the laser scanner was not that bad. I think the laser scanner package I bought, it was about a $700 package, but it was a Kickstarter, and I got it for like $350. So it was hard to pass up. Yeah, that's so I'm just stoked to actually get it and start playing around. I've wanted to, there's been lots of laser scanners around for a while, but none of them, or 3D scanners around for a while, and none of them have just really been exactly what I wanted. And this new one, what brand is it? The new one that I got is it's from Creality. It's their new CR Scan Lizard. They had the CR Scan before, and it was okay, but now this is their new generation. Some big improvements, and from what I've seen, I'm still staying somewhat skeptical, but from what I've seen, it's going to work for my application, because I've seen the applications that it's being used on, and for what I need, I am going to be absolutely, the detail that it has, I will be more than capable of working with easily. So I'm pretty confident that it will work. Really think a budget scanner is going to be accurate and easy to use. It appears to be accurate enough for this scale of things that, yes, absolutely. Easy to use. I mean, scan data in general. I've worked with scan data a lot in my professional career, because it was something that we used on very large scale, like roadway design. We would fly an area with LiDAR, and then we also have point scan LiDAR data, and then we would have to try and 3D scanning data is never clean. It always takes work. It always takes cleanup. And you have to just use it as a reference with things that you can absolutely determine are what is appropriate. So that's the big things. It's like, it's not just an object that's going to come in perfectly and be like, I've got exactly what I need. It's just like, you have to use some intelligence and choose what you think are the things that you can just plan on being reliable enough that you can build with some tolerance. And that's the lesson that it really you need to learn before you're ready to just dive into it. So that's what I'm They were awful, pretty sure. So, yeah, I mean, 3D scanners have started to come. They've made big leaps in the last like 3 or 4 years. The good ones, like I've used the Peel 3D before, which is like a $30,000 scanner, and it's great. Takes a ton of horsepower. The outputs are massive. Takes a lot of cleanup. I also need to learn like Mesh Mixer better, things like that. Let's see. I want to build a 1/10 scale wrecker tow truck, middle duty truck to match my middle duty rollback. Yeah, I mean, you gotta start somewhere. A lot of design time, a lot of fabrication. That's there's been some tow truck stuff, but yeah, it's just gonna take a lot of work. Likely not going to be cheap. Always has noise. Yeah, scanning. It's I'm confident enough because I've worked with it enough that I know what to expect. And from what I'm seeing, I think it'll be work. I had worked with Ferro in Invometric, Polyworks 2-head laser scanning in my work as a CNC machinist. I'm sure you will benefit from 3D scanning. The Ferro arm stuff is like top tier too. Ferro arm, it's got, it's the accuracy is so good because it's got positioners throughout an actual nice head. But I think those are like upwards of $200,000. But they're absolutely like the pinnacle of of it. And by all means, I would love to have that Ferro arm here on the side. Aspiration, one day. Is there such thing as 3D mapping tool where you could just pick up certain points on a model? So basically, it's going to take the points that it creates, and then it is going to put that into a mesh or a surface. So you're basically going to use that surface as a reference. So it's kind of like what you're talking about. As far as like an easy way to take that and then just be like, oh, just pick these things and make these things into this super usable, perfect model. Like, no. You can export a solid model from this new scanner, but to actually think that it's going to be usable is a hilarity to me. I have no aspirations of that being something. Because the other thing is that you have to get such a perfect scan that you have no holes in your model. Now, it'll fill some holes automatically, but it's just not a thing that I'm even concerned with the thought of. So if it ever works that way, fantastic. The fact that it probably won't, I'm absolutely fine with as well. But I think it's going to add another interesting tool to all of the rest of the tools that I've added to this workshop to build funny toy trucks. But we've got way off the subject of anything actually probably useful to nearly any of you. But we looked at 2 chassis rails. I'm not going to save this. I don't need this for any reason. What brand is your vacuum form machine? It is it's like VacQQ, something like that. It's like VACUCU. I got it off of oldtimerc.com. So they have 2 different sizes, an A3 and an A4. A4 is like 8.5 by 11-ish, A4 paper. So, and then A3 is closer to 11 by 17, and that's the one that I have. So you're going to make a motorized rotating table and rotisserie for the said scanner. It comes with that. It's included because the rotating table. It's got the rotating table on there has certain shapes so that it can automatically drop out the table in post-processing. Little things like that are cool functions of the software. So why is it just live chat on this video? I'm not understanding. I don't know what you're saying. But yeah, that's the basics of what we've got going on. I guess I could save this since it was a recovery file. Leica is a nice system too. All of these sound very expensive. I'm trying to find nice enough to work in my RC hobby room for when I decide to use it roughly 3 times a year. Let's see. Oh, here's the next mold in case you guys were interested in the class 1. This box here is all to mold this piece of the cab corner. So I'll show you guys the this part of the box here will slide out. That's like the final slide, or the compression one. The actual goes in. Do any of your personal projects inspire projects on the VP side? I think that always it kind of has to. Like if we're not building things, we're never going to know what we want in the new one, right? So I think so. I think that it has to. But so this is the press piece. So after I load this mold with carbon fiber, this will be the plunger part. But the problem is that how the taillight housing goes in. See, it's at a little bit of an angle. Well, I wouldn't be able to actually pull that out of the mold straight because it's got like an undercut. So it's almost like locking it in place. So that's why I had to make this piece. Let's see, can I separate that yet? Well, so I can actually take and I can disassemble the 2 halves of the mold like that. So that piece will come off because there's some undercuts here. So that will separate that half. And then this is a slide. So that part, let's see if I can. That part will slide out of the mold to undo the locking force that this taillight would have. And at that point, I can likely just pull this out straight sideways. Well, actually, I couldn't. I needed to be able to have this pull out so that because there was an undercut here and I wouldn't be able to pull it out without that locking in because there's another kind of undercut on the side there. But regardless, a 1, 2, 3, 4, 5-piece mold for that cab corner. What resin do you use for carbon composites parts? It is which one is it? IN2 resin epoxy. It's a thin epoxy, which is needed so that it flows in the best way. You better get working on that C1. Wasted 4 days last week, and now you're spending 2 hours re-app. I know. It's exactly it. And that's the rest of my day. Yeah. I'm mainly doing it because I'm nervous about getting the rest of this done. Do you put any kind of sealant between the mold pieces to minimize flashing? I use, no, specifically, because part of like what they talk about with the compression molding, forged carbon, is that you add extra resin. It's supposed to be a 60-40 split between carbon fiber, chopped toe, and 40% resin. But you basically make the same amount, or you make 25% more resin than the carbon fiber. So you have to squeeze out a large amount of resin, and it has to have a way to get out. So it's supposed to come out of places. So I use a mold release wax, a high build mold release spray on. And then from there, that extra resin just finds ways to come out. I see your C2 is for sale on your site too. I'm going to buy it the day before you leave. I know, I need to remove that because someone emailed me about that the other day. I was like, oh, I don't know why that's on there anymore. Like it's not for sale. need to go remove that. Eek. Will you have everything ready for Scale Nationals? Can't wait for your vlog. I hope so. I hope so. It's getting crunch time. So I hope you guys have a good rest of your Sunday. I yapped this on for as long as I could. I made it an hour and a half rather than just an hour. Hopefully you guys have a good rest of your Sunday. I have a list of things to complete. My book of things to complete. In the my notebook that is brilliant ideas I'll never act on. Will you post a video of one of your carbon forging sessions? Go back to my Road to Scale Nats videos. I've posted one or two of them showing it. Yeah. Again, hope you guys have a good Sunday. And that's all, folks. We'll see you for the Scale News update. I gotta get to work. Later.